Let's get back and talk to some of these applications. Again, so we talked about Wi-Fi calling, and Wi-Fi calling round trip latency, round trip time is important. Packet latency is, Wi-Fi calling is very sensitive to any kind of a packet latency. So that's a key thing for Wi-Fi calling, a key requirement for Wi-Fi calling. So another one you guys have talked about was video conferencing. Jeff, you mentioned some of the things. FaceTime is a video conferencing application, so that's another one we talked about. Video conferencing, Wi-Fi calling. So Chaz, what about in your industrial type applications? And you're looking at like the rural agriculture. What type of equipment is out there that might need to connect to that Wi-Fi besides just somebody's smartphone? Right? What else is out there?
So the time clock is the one that first comes to mind. That's probably the most common next item on the list that we'd see that's connected after maybe more traditional IT type devices. And those time clocks can be finicky. They want to be on, and like any other IoT device, there's just not a lot of intelligence built in, meaning troubleshooting is always limited. And then in addition to those, there are some remote wireless type badge scanners. That used to be more of an issue. Now a lot of times those apps are built into the mobile devices, so that's improved. And there are some other vehicle and equipment monitoring things, but I think one of the reasons we haven't seen a ton of that is because there hasn't been that type of outdoor reliable Wi-Fi network present at these locations in the past, so we haven't been getting those requests.
It's the IoT. We've been hearing about that for so much, right? So many years. It's quietly taking over, and it doesn't. IoT is kind of that weird word that people define in all different ways, but really when it comes right down to it, it's really automating many things that we used to have to do manually. We can now automate them, and using a network connection to bring some automation to different types of applications and environments. Jeff, you're talking about I want to go back for a minute to you described your outdoor network for the Olympic trials, and you described initially that you had data access so that the teams could have access. You have Wi-Fi calling, you have video conferencing, you had live streaming, upstream live streaming. So there's 4 different things there. How did you handle all of that? With you've got 4 different services all competing for essentially the same pipe. What's your strategy there?
Yeah, prioritizing the device based on its connected SSID in the device is how we handled it. So we didn't have the budget, we'll say, for that location to put devices upstream, right? It was literally a Cambium backhaul radio. We used 450Bs from a school close by that had some fiber, and went through some trees, got there, right? And then handed off into a dumb switch, which then went to these APs. So we didn't have anything to do a lot of the intelligence around traffic shaping or QoS or anything. And so we relied on the QoS features inside the access point based on SSID and device connected.
Okay, so you applied the QoS right at the access point. How about, did you rate limit did you create any rate limits to create some separation in the traffic?
We did. So we did not rate limit, obviously, the video traffic or anything that was regarding the live streaming that was happening there. But we did limit per user. So we limited the devices per user on the open network, right? The guest access.
Right.
And we limited that just so we could say, hey, what's a fair amount of bandwidth that someone could use here? That's not going to limit them. It's going to give them a quick download if they need a picture download or whatever it is, as well as a quick upload if they're uploading a video to Facebook or something like that. So we did rate limiting per device as well to do a fair amount of bandwidth for each device that was connected to the public open Wi-Fi.
Okay, so people are going to ask, what was the number you used?
Yeah, 25 megs.
25 megabits.
Yep.
Okay, because they're going to ask, right?
They're going to ask. Yeah. And I'm definitely someone who believes that if you could give them more and still have some fair queuing in there, you should open it up to them, right? A lot of hotels these days are still trying to push 10 to 20, 30 megs of bandwidth to a subscriber in the room, even though it's free. And the hotels that we manage, we aim for 100 minimum, right, to those devices. And designing for what they can do futuristic, not the other way around. So We did 25 based on our limitations around what was at that event, and also the first time using these outdoor APs.
Okay, so let's talk about the types of devices a little bit, because that has a big impact on the overall network performance, right? Because ultimately, there's a connection between the device and the access point. There's a connection. There's a wireless connection between those two devices, and so there's different capabilities of those devices. There's different firmware, different technology. So, Chaz, I would think in the IoT space and sort of the industrial type applications that you do, that you see a lot of that. You see different types of devices, different types of capabilities on those client devices, and different types of firmware. Is that fair statement?
Yeah, and not only that, I mean, in addition to seeing the different types of device and having a true lack of uniformity around, say, firmware, then you run into things like, oh, when you program this particular clock, let's say it needs this, and this box checked, or else it's going to download all these other things and it won't work right. And it's just so not, it's, for lack of a better word, it's so not a PC that you can just manage properly and set the policy the way it should be.
Yeah.
Are those,
I would imagine that there's, oh, sorry for interrupting.
No, please,
I just
go ahead.
throw in there, I'd imagine that you still run into things like no dual band radios in those devices too.
Exactly.
Right?
Yeah, that would
So
be,
you only
thanks for
have 4
pointing
gig
that out.
or 2.4 instead of 4 and 5, right?
Yeah.
That also becomes a struggle.
Wow, that's a good point. Chaz, do you see on these IoT devices, is there a particular preference for band? Do they tend to prefer 2.4, or is that?
Oh, Jeff's
see-
accurate. Yeah, I mean, a lot of these devices, we've had some where we like boot them up and they don't even see it, and we're like, oh yeah, that's right, we did this network in 5 only, and that's why I can't see the device.
Okay, right. So so we can't shut off 2.4 gigahertz anytime soon.
Not quite yet. It's bit us every time we've done it. How about that?
I think that's true, as well as, I don't know if you've seen this too, but I've seen where some of the, we'll say, goal of $100 netbook type things, right? They're using wireless cards that are from 5 years ago still, trying to keep that cost down, right?
Exactly.
And on things that are not backwards compatible or accepting lower bit rates, they don't even see the wireless network sometimes.
Yeah, we've thankfully, some of our larger districts have at least been aggressive about addressing that, because they know how negatively it impacts everybody else.
Yeah.
So, but we have seen that, and yeah, that's just another example of a true pain point when you're trying to support so many different and various clients.
So we do need to keep, fortunately, the newer devices, newer access points, all dual band, and support all the newer protocols. So hopefully we have the right level of backwards compatibility and can still handle that.